Today we're finally going to learn what the derivative is. And before we do that, we're actually going to start off with looking at the slope of the secant line that's in this picture here. Let's see. So if we were to try and find the change in y over the change in x, let's think about what that would look like. Well, the y value here is f of x plus h. So f of x plus h. Okay. Then minus, and the y value here is just f of x. And then on the bottom here, we have the x value here was just x plus h. And then the x value here is just x. And if you simplify that there, we get f of x plus h minus f of x all over h. And so you might recognize this formula. This is our difference quotient. And there's something else you might remember about this. Let's write this here. Before I keep writing, I want you to think about this for a second. What happens when we let h go to 0 with this difference quotient? What does that tell us geometrically? All right, so it tells us the slope of the tangent line to f of x at x equals, actually let's just say at x. Can be found by observing as h goes to 0. Okay. So we pretty much actually had the definition of the derivative before we even got here. Okay. So we've already done this part here in the blue. We've looked at these quotients and we've allowed h to get to 0. Okay. We found the slope of secant lines over smaller and smaller and smaller intervals, and it usually approached some number, and that number was the slope of the tangent line. And that's actually what we're going to define to be the derivative. Let me try and write that a little neater. All right, so there's a couple things that I want to say here. One, this is our notation for the derivative of f. And again, the derivative of f is found by just taking this limit here. And then the other thing, actually the other thing we'll write on the next page. We'll just leave it at this. And by the next page, I meant right here. There's two important concepts that I want us to know about the derivative. The first one we've actually kind of already written, and that is that f prime of a is equal to the slope of the tangent line of f at x equals a. And the other one is that f prime of a is the instantaneous, and sometimes we'll leave off this word instantaneous, rate of change of f at x equals a. And there's actually even one more thing I want to say about that. If we were to actually take the derivative of f at a, the units, what would the units of those be? Well, remember, we found this using the difference quotient. Well, the limit as h goes to 0 of the difference quotient. But on top of that quotient, we had units of f, or if you prefer to say units of y, and then this was over units of x, whatever those inputs are. Next on our list here, we want to talk more about the notation for the derivative because there are actually several different notations for the derivative. So the first one that I want to talk about here is dy dx. And what this means. This is the derivative of y with respect to x. And so we'd usually use this notation if our function is given in the form y equals something. Okay. Now, if our function is actually written in function notation, like let's say f of x equals something, we'll write it almost in the same fashion. We'll write over here df dx. And this is the derivative of f with respect to x. And the reason we're adding this with respect to is we can actually take derivatives with respect to other variables. Next on our list here, we have f prime or y prime of x, depending on which notation we're using. Let's start off with maybe y prime. This is the derivative. And actually, yeah, let's just leave this. The derivative of y. And when you use this notation, we're not actually saying what it's with respect to. It'll just be implied what variable we're differentiating with respect to. And then the next one, f prime. This is the derivative of f. And kind of the nice thing here is if you do have this notation, you're probably going to write what your variable is here. And so then we know, oh, we're going to differentiate with respect to x. So it's the derivative of f with respect to x. And I'm going to put down two more of these here. These other two aren't used quite as frequently, but you could actually see y dot at the top like that, and this is just the derivative of y. And also just this capital D. So d of f of x. And so this would be the derivative of f with respect to x. And the only reason that I know that this derivative is with respect to x here is that's our only variable, x.